This video covers graphing a linear inequality on a number line. So, first off, what's a linear inequality? Well, like linear equations, except instead of an equal sign, they can have less than, greater than, less than or equal to, or greater than or equal to. What's nice is they also have many more solutions, sometimes infinitely many solutions. And we graph these solutions on a number line. We can use a solid dot to indicate that endpoints are solutions. So when I have x is less than or equal to 11, right, I have to take all the numbers less than 11, but I also have to take 11 itself, right, because it's less than or equal to. So that endpoint is part of our solution. We use an open dot to represent endpoints that are not solutions. That's for greater than and less than. Because if x is greater than 11, I need all the numbers greater than 11, but 11 isn't greater than 11, so it's not included, but like 11.1 would be, 11.00001, right? All those numbers close to it. So the key takeaway is for greater than or equal to and less than or equal to, it's a closed dot, and for greater than or less than, it's an open dot. So let's practice. We're going to graph 3 examples. Hi, Bobby. We're graphing. That's my cat. Okay, so I have A as less than or equal to 0. So I know 0's going to be part of my solution because A is less than or equal to 0. But I need to find some numbers that are less than 0. So I sometimes like to do this by taking a test point on like either side, you know. If I have -2 is less than or equal to 0, is that a true statement? Yeah, that's true. So -2 would be in our solution. So I know to shade this half of my graph. If I had picked 2 and said 2 is less than or equal to 0, that's false, right? We don't like that, right? So we know that this half of the line would not be in my solution. Let's take a look at example 2. I have -2 is less than C. So -2 is not going to be part of my solution, but I know that -2 is less than C, so I should pick some numbers greater than C. How about, greater than 2. How about 3? -2 is less than 3. That's a true statement, so I'm going to shade to the right. For our final example, I have x is greater than -10. So here's -10. It's not included in my solution because it's strictly greater than. It's not greater than or equal to. And what we need to do now is pick a number greater than -10. How about 0? 0 is greater than -10. This is true. So I'm going to shade this right-hand side of my number line.